So let's start revision. We have three laws: law of conservation of mass, law of multiple proportion, law of definite proportion. So what is the difference between three laws? Look here. Law of conservation of mass, which state that mass neither created or cannot created nor destroyed during a chemical reaction. For example, if I have 4 grams of hydrogen react with 2 grams of oxygen, for water, the mass of water will be 4 plus 2, 6 grams. So the mass neither created nor destroyed during a chemical reaction. The conclusion of that: reactant equal product. Mass of reactant equal product. What about what about sorry here what about law of definite proportion? Law of definite proportion state that chemical compound always contain the same element in exactly the same proportion by weight or mass. For example, carbon dioxide. We have carbon and oxygen. Carbon, the ratio of carbon 1 to the number of atom of carbon here 1, while the oxygen 2. So the ratio of carbon dioxide 1 to 2. This is a definite proportion. What about multiple proportion? Multiple proportion state the law that states when two elements combine to form two or more compound, the mass of one element combined with a given mass of other is in the ratio of a small whole number. So if you have two compounds made up of the same two elements, carbon and oxygen, here another sample, carbon and oxygen, so the ratio of carbon in the two sample 1 here and 1 here. What about oxygen? Here 1 and 2. This is a multiple proportion. So the ratio of oxygen 1 to 2 in the two compounds. Given the following data for two compounds SnO2, SnO2, what gram of Sn in the first compound 100 and in the second compound 100, while in oxygen 13.5 and 27. To get the ratio of oxygen in the two compounds, we should divide by the lower number. Here, which is the lower number, which is the least number, 13.5 or 27, 13.5. So 13.5 divided 13.5 here, divided 13.5, 1. While here 27 divided 13.5 equal 2. So the ratio here 1 to 2. And it's follow law of multiple proportion. As it's follow law of multiple proportion. Why? Because two compounds made up of the same two elements, Sn 10 واكسجين Sn واكسجين Sn واكسجين. تمام. Here I want to answer this one. Carbon form two compounds with oxygen, carbon monoxide and carbon dioxide. Carbon monoxide and carbon dioxide. Sorry. Carbon monoxide and carbon dioxide. Here, number 12. One compound of the same mass of carbon, what would be the ratio of weight of oxygen in two compounds? The ratio of oxygen in two compounds will be here 1 atom and here 2. So the ratio 1 to 2. In compound carbon monoxide, we have 10 grams of oxygen combined with each one the oxygen, this is oxygen and carbon, and 1 gram of carbon. In carbon monoxide, how many grams of oxygen? So carbon monoxide, carbon dioxide, the ratio of carbon 1 and here 2. Carbon or oxygen, carbon here 1 gram and here also here 1 gram. What about oxygen in the first compound in carbon monoxide? 10 grams. What about here? to get the amount of oxygen here, we have here 2, the ratio of oxygen here 1 to 2, so multiply 10 power 2, so the answer will be 20. The oxygen amount of oxygen 20, as we multiply 10 power time 2, as we have in the second compound 2 oxygen at the ratio 1 to 2. We have 4 scientists. This is a very important. We have 4 scientists. Dalton said that atoms of the same element are similar, atoms of or alike, atoms of different element are different. So the answer will be B of Dalton. Democritus was the first one who ever mentioned the word atom or described the word atom. Consider the matter is divisible to point of a particle which can no longer be divided. This particle is the atom, which is D. Thomson said that atom is a positive charge. Imagine atom in the positive charge embedded in a negative electron. This is Thomson. Millikan calculate only the charge of electron. So here draw Thomson model, which is called Blum budding model, as he imagined that atom is a positive charge embedded in it negative charge like this. This is a model formed at Thomson. Rutherford make experiment called gold foil experiment, as we use a gold foil like this and use an alpha particle. When the alpha particle passed through the gold foil, he saw that most of the ray passed through gold foil. This means that most of the atom are empty, as to through the rays, and so that when some rays deflect like this means inside the atom there is a positive charge like alpha particle, as alpha particle made up of the properties that describe alpha particle has a positive charge. This mean what? This means that inside the atom this is a nucleus, and inside the nucleus there is a proton particle contain positive charge. This is a Rutherford experiment. يبقى in what atomic model negative electron orbit the positive charge nucleus in Rutherford. Whose model determined that an atom positive charge is concentrated in the atom center? Rutherford shot what at the gold foil? Shot alpha particle. A positive charge particle found in the nucleus is called this positive charge called the proton. As this is a proton, positive charge called the proton, and the negative charge called electron. Inside the nucleus there is another particle which is a neutron, no charge, called the neutron. A nuclear particle that has no charge is called what? Called neutron. Nucleus of an atom has a positive charge, as we draw a positive like this, proton. So nucleus has a positive, while atom neutral charge, while atom number of positive charge equal number of electrons. So here we have here one positive, يبقى so the electron number of electron 1. So atom is a neutral while nucleus positive. Sorry. Number of proton of each atom of that element called atomic number. For example, if I have here hydrogen and 1, the number above the hydrogen called atomic number. Atomic number is the same as number of proton. And I said before that an atom is a neutral, so number of proton equal number of electron. So atomic number equal number of proton equal electron. 3 atomic number equal number of proton is the number of proton equal number of electron is the number of proton of each atom of that element, atomic number. So atomic number mean what? Number of proton. What about mass number? Or mass number equal proton plus neutrons. As I said that inside the nucleus there is a neutral. There is a neutron. So the mass number equal positive plus a neutron. Proton plus a neutron. This is a mass number. What about isotopes? Our atom of the same element having a different mass due to varying number of neutrons. For example, if I have here carbon, mass number of carbon 12, and another sample carbon 13. Mass number, I said this is a mass number, 12 is a mass number and 13 is a mass number. Mass number equal proton plus neutron. Mass number here 12. Number of proton or atomic number of carbon 6. So carbon atomic number of carbon 6. So number of proton is 6 plus neutron to get for the first one number of neutron 12 to get number of neutron equal 12 minus 6. So the number of neutron equals 6. What about second compound? Carbon 13. This is a mass number. Mass number equal proton plus a neutron. Proton 13 plus a neutron. We know we want to get the neutron. Mass number 13 here. Sorry, proton 6. Now atomic number 6. Mass number 13 to get number of neutron equals 13 minus 6. So the answer will be 7. So what is the difference between carbon 12 and carbon 12 and carbon 13? The difference will be in number of neutron, but number of proton is same. This is called isotope. So isotope are atom of the same element having different mass number due to what? Varying number of neutrons. Atomic number of an atom is the same as number of proton. Is a total number. This is isotope. Total number of proton plus neutron, which is called what? Mass number. Here, how many neutrons are present in an atom of 10 that has atomic number 50? Atomic number here number of proton equal 50. And mass number 119. What about number of neutron? Mass number equal proton plus a neutron. Proton 50. We want to get a neutron while mass number 119. I think the answer will be 69. We should subtract 119 minus 50. Here we want to answer this one. Chromium 58 and chromium 63. Chromium 58 is a mass number, while 63 also mass number. This type or this method or this process is called hyphen notation. In hyphen notation is a method used to write isotopes. Hyphen notation. In hyphen notation we write element then a mass number like this. Chromium then mass number 58 is a mass number. This is a hyphen notation. Chromium 58 and chromium 63. To get the number of proton, we should to look in a periodic table and know the atomic number. As the atomic number of chromium 20, atomic number 20. So number of proton is 20, and here 24. So here 24 and also here 24. Number of electron, I said before that the atom is neutral, so the number of proton equal number of electron. So here 24, so also here 24 and here 24 in proton and electron. What about neutron? To get the number of neutron we should to subtract 58 minus 24 as mass number equal proton plus a neutron. Proton 24, we want to get mass number 58. To get a neutron, we should to subtract 58 minus 24. The answer will be 34 here, and 30, I think 39 here. The rest of page is the same as chromium. Here you use using right hyphen notation. We have here carbon with 6 proton and 6 neutrons, carbon with 6 proton and 7 neutrons, carbon with 6 protons and 8 neutrons. To write hyphen notation, element, then a mass number. Here the name of element carbon, we write carbon, then a mass number. For the first compound, mass number equal proton plus neutron, so 6 plus 6, 12. Second one, carbon, then write a mass number. Here 6 plus 7, which is 13. Carbon, 6 plus 8, 14. This is hyphen notation. And the rest of problems is the same as first one. Here want to write hyphen notation, but we have here atomic number and mass number. Atomic number, we use the atomic number to look in the periodic table, as we should to search in atomic number 2 in the periodic table, and we will find that the name of element will be helium. So helium is the element with atomic number 2, and write mass number 4, helium 4. This one, atomic number 8, oxygen with atomic number 8. We know it by when searched in periodic table. Oxygen, then mass number 60. That's it. Here, which is last one. How many neutrons are present in an atom of sodium that has atomic number 11 and mass number 23? Mass number equal proton plus neutron. We want to get a neutron, proton, which is atomic number 11, mass number 23. To get a number of neutron equal 23 minus 11. That's it. The rest of problems is the same as first one. All atoms of the same element have the same atomic number? No. Yes. All atoms of the same element have the same atomic number? True. All atoms of the same element has the same number of proton and neutrons? No. False. Atomic number is the number of proton and the neutron in an atom of the element? False. This is a mass number. That's it. Thanks for watching.